For my capstone project, I chose to do research into race and gender bias in face recognition technology. So, what is face recognition technology and how does it work? Well, it's a biometric software application that is used to identify or verify a person based on facial features. It analyzes facial structures and provides each face with a unique sequence based on our 80 existing nodes. A node is like the distance between your eyes and the width of your jaw. When there's a positive identification, it means that there's a strong confidence level match between two images' nodal sequences. More on that later. Now, the big players, which does not include companies that have a smaller, more niche focus on face tracking technology, are Facebook, SenseTime, Megvii, Microsoft, IBM, Amazon, and Google. You'll notice that this list features only two countries. That's because the US and China are the biggest producers of high-tech AI companies, though they are by far not the only ones. Now, who's actually in the databases that all these different face tracking algorithms pull their images from? Well, to put it simply, it's you. Unless you're an online ghost, you're likely in at least one facial database. To be clear, there are thousands of different databases with different purposes and different identification standards. Not all databases are created equal. Social networks, dating sites, photo websites, and surveillance cameras have all had the chance to record or save an image of you, usually to expand their accuracy rates, suggest photo categorizations or tags, or, more unfortunately, to sell it to third parties. An interesting example of a company image repurposing would be Everroll, a photo management app that launched back in 2012. It collected over 13 billion images before discontinuing the app in 2016, renaming the parent company Paravision, and launching a face recognition software training program with those same 13 billion images, only to become the number 3 most accurate algorithm tested by the National Institute of Standards and Technology and provide services to law enforcement. Now, on that note, let's talk false positives. In 2019, NIST, the National Institute of Standards and Technology, released a report that tested 189 different algorithms by 99 developers around the world. I want to explain the different types of verification they used in their study. One-to-one verification is when two images are fed into the system and it must report back whether or not it's the same person. Think Face ID to get into your phone. When you first set it, it identifies your nodal sequence, and every time you attempt to log in, it matches the sequence it has versus the sequence it's identifying from your face in real time. Now, one-to-many is when one image is fed into an algorithm, which then cross-references that image sequence with every image in the database to find a match. Confidence levels, like where it says 91.2%, means that the sequence was a 91.2% match. There's no universal standard for confidence levels, which can be quite problematic. One-to-many is used in cases like criminal database checking and is generally what one thinks of when they think of face recognition technology. Now, that third one is a method NIST used was one-to-one versus one-to-many to check for demographic differentials between the two applications to see if there was a difference in how the algorithm performed. This is where false positives and subsequently false negatives come in. A false positive is when the algorithm claims two images or faces are the same person when they are not. And a false negative is when the algorithm claims two images or faces are not the same person when they are. With that in mind, I want to highlight the racial bias that NIST discovered in many of those tested algorithms. In high-quality application photos in the US, the Black and East Asian demographic had the highest false positive rates, while Eastern European had the lowest false positive rates. This differed by up to a factor of 100. To clarify, many algorithms would falsely match two different people and claim they were the same person, especially those with darker skin tones and East Asian features. In a predictable reverse, high-quality application photos in China resulted in the East Asian demographic having the lowest false positive rate out of all the other tested racial demographics. Even more concerning, NIST found that US law enforcement algorithms output the highest false positive rates in American Indians, with elevated false positive rates in African Americans and Asians. Again, to clarify, these law enforcement systems had high rates for wrongly identifying minority demographics like American Indians, African Americans, and Asians. That same report found that women have higher false positive rates in all of the tested algorithms. A study by Colorado University of Boulder tested 4 algorithms from major companies: IBM, Microsoft, Amazon, and Clarify. Notably, Google was not included in this test because it doesn't do gender recognition. In the report, CU Boulder fed these algorithms 2,450 images from Instagram that had been labeled by the owners indicating their gender identity, and found that transgender individuals were wrongly categorized 38% of the time, Non-binary individuals were wrongly categorized 100% of the time because the algorithms were based on a gender binary, with the only possible results being female or male. The study also found that the algorithms reinforced gender stereotypes when a male with long hair was wrongly identified as a female. The conclusion that both of these studies drew was that darker-skinned females and those on a gender spectrum that exist outside the binary had the highest false positive rates in identification and categorization. Now, the consequences of face tracking technology used incorrectly or loosely are pretty dire. For one, it can lead to wrongful conviction, like in the case of Stephen Talley on the right, who was arrested and beaten outside of his home when a Denver law enforcement face recognition software wrongly identified him as a man who robbed 2 banks and injured a security guard. The mistake cost him months in prison, trial fees, his family, and astronomical medical fees from when the officers beat him for allegedly hurting one of their own. And how they figured out it wasn't him, you ask? Well, Steve was about 3 inches taller than the perp. He had a mole on his right cheek that the face examiner had failed to identify, and was also proven to be at work during both incidents, which was caught on surveillance camera. Now, another consequence is that AI lacks context that we as people inherently have, such as in the case of Richard Lee from New Zealand, who tried to update his passport only to receive an error message that said, "The photo you want to upload does not meet our criteria because subject's eyes are closed." New Zealand Department of Internal Affairs claims that its face tracking technology is some of the most advanced, and it was an issue of lighting. Sure, maybe, but humans wouldn't have made the same mistake. Of course, this example is fairly lighthearted. Richard himself posted the situation on Facebook, but the point is that technology ultimately only created an obstacle in civil use. Other consequences include, but are not limited to, government overreach, a surveillance society like think 1984 but real, privacy concerns, and data breaches. Lawmakers are scared of these consequences, and they should be. As of current, 4 cities have banned face tracking technology. Ironically, San Francisco was one of them. So, let's talk future. Currently, the FBI database consists of over 641 million images and identities, and this is only growing. It's not necessarily a bad thing, because the more data it has, the more accurate any algorithm would be. But still, keep it in mind. As of right now, Utah, Washington, and Vermont allow undocumented immigrants to drive legally, but the DMV is legally obligated to share all of their collected data with U.S. Immigration and Customs Enforcement. Last year, in 2019, the U.S. Customs and Border Protection's Travelers Database, which contains any information the government requests of you to participate in air travel, was breached and data ended up on the dark web. Soon, in October of 2020, all U.S. airport travelers will be required to show their passports or new federally commissioned driver's licenses for domestic travel. And this same year, China will be rolling out its social credit system, which will use face and biometric recognition technology to do civil surveillance on its citizens and record infractions like jaywalking. And that social credit can affect your ability to rent an apartment, much like a credit score but more invasive. By 2022, the Department of Homeland Security will use face tracking technology on 97% of airline passengers. Future uses without a due date and primitive current uses include retailers using face identification payment at checkout, verification and attendance tracking, and breaching of school grounds. It's not all Big Brother in a bad way. Some of it is fairly benign. One of the more benevolent uses include identifying missing children by technology company Face First, which is a growing service provider for that specifically. So, with an ever-growing market for this technology and its primary uses being surveillance and marketing, it's incredibly important to be educated on the consequences of race and gender biases that are unwittingly coded into these algorithms. The ramifications of ignoring the reports that outline these biases are that systemic racism and gender inequality and erasure will only be enabled by artificial intelligence. Diversity and inclusion must be at the core of these systems, and anything less will only worsen this problem exponentially. In conclusion, smile. You're on camera.